So today, 3.6, we're going to do what we did in 3.5 because I remember they didn't teach you the possible rational zeros test, but I did. Okay, so that's what we're going to be using today. So possible rational zeros states the possible rational zeros. It tells you they exist, but it does not tell you what they are. Remember, it gets that pool from infinitely many numbers down to a few numbers. So you take the factors of the constant divided by the factors of the leading coefficient. So when you are doing your assignment, make sure you pay attention what it's really asking you, because sometimes it's just asking you for the possible rational zeros. Don't freak out in trying to find the zeros. Just list the possible rational zeros. Emma, I had you down for an activity today. Were you supposed to go somewhere? Yeah. Okay. Okay, so list all possible rational zeros for the equation 4x to the fourth plus 13x cubed minus 124x squared plus 112x minus 8. So if I told you to find the zeros of that, you couldn't factor it by grouping. You couldn't factor it by binomial factoring. You would need to do something to get it possible for you to be able to factor it. So we would list the possible rational zeros, which I just call P, R, Z. For what? What's PRC stand for?
Possible rational zeros.
Okay, so remember it's plus and minus all of them, but we don't really write it, right? Okay, so what are the factors of 8?
4 and 2.
Okay. I usually start at 1.
1 and 8.
1 and 2 and 4 and 8. If you want to write them 1 and 8, 2 and 4, that's up to you. I think it helps to write them in order. Okay? And over the factors of the leading coefficient, which is 4. So what are the factors of 4?
1, 2, and 4.
1, 2, and 4. Again, it is plus and minus all of them. If you look at your answer in the book, it would go plus or minus 1, comma, plus or minus 2, comma, plus or minus 3, not 3, 4, plus or minus 8, plus or minus, all of them reduce. 1/2. Where'd I get 1/2 from? 2 over 4. I got 1/2 over. What other fractions do I get? And well, it's also here just the 1, right? 1 over 2 and 1 over 4. Okay. You can write them out like that, but it's easier just to write them like this and know that you can make fractions. Okay? Yes?
So you just do the first and the last number?
Yes. The factors of the constant divided by the factors of the leading coefficient. So do you have to have it written in the correct order before you do this? Yes. Okay. You try for the next one. 7x to the fourth plus 13x cubed minus 124x squared plus 112x minus 45. What did I change only? Did you get 1, 3, 5, 9, 15, 45 over 1 and 7? Okay. So one of the possibilities could be 9/7, couldn't it?
Yeah.
Yeah.
That'd be great. Ooh, what about 45/7? You want to try that one first?
Yeah. What did all those real questions? Well, isn't it? Oh no, it's not. Never mind.
You're not going to start with the fractions first, are you?
No, I was thinking
We're gonna
that 7 was a 9.
Yeah.
That's just-
So we're going to start with 1 plus or minus 1, 3, 5, 9, 15, 45 before we go into the fractions, right? And hope it's down to the 4th. So I only have to do this, goes to the 3rd, to the 2nd. I only have to do it twice before I can, if nothing else fails, like if everything else fails, I can use the quadratic formula, correct? So odds are I don't have to get to the fractions. That can come out some other way. But if sometimes do you have to use a fraction? Yep. And then you have to remember to get common denominators and all that kind of fun stuff because that's what happens with fractions. Okay. So if p of x is a polynomial of degree n is greater than 1, so greater than 1, yes, then p of x equals 0 has exactly n solutions in the set of complex numbers. So whatever the degree is, the n, so it says is n is greater than 1, that is exactly how many solutions it has on what numbers? Complex numbers. Okay, so if I have a degree of 8, how many zeros do I have? 8. Did I say they were all real? Nope, but there are what? 8. Okay, if p of x has any factor of multiplicity m, count the solution associated with that factor m times. So x minus 4, evidently, to the 7th. How many factors is that? 7. And I'm only looking for one more to go with the 8, right? Okay. That just says x minus 3 to the 4th equals 0 has how many solutions? 4. Okay, what are all the complex zeros of the polynomial equation? So I'm looking for all of them, yes? Okay, so when I look at a polynomial, if I can do binomial factoring with my x, that's the first thing I do. Because that's the easiest, it should be the easiest. Can I do that? Do I have a quadratic or a trinomial that I can do that with? No, so I can't do that. So if I can't do that, I can't do the quadratic formula because this isn't a trinomial set up in that pattern, is it? Nope. Can I factor by grouping?
No.
Why not?
The 3?
There's 5 terms. When you factor by grouping, you have to have an even number of terms to group, don't you?
Yeah.
Yeah. Okay. So I can't factor by grouping. So I can't go through all this. Did you see what I did? I went through everything you've been taught, right? Normal factoring, quadratic formula, factoring by grouping. So none of those work. So now I have to use division. I can use long division if I knew some of them. But do I have a way to narrow infinitely many numbers down to a few? The possible rational zeros, right? So I have PRZs that will help me get this down to some smaller amount. Because it says complex zeros, so I'm looking for all of them. So I'm hoping there's at least one real zero in there, aren't you? Okay, so what goes in the numerator? The factors of the constant. So is it in order?
Yes.
Yes, so my constant is 2. So what are the factors of 2?
1 and 2.
1 and 2. And just put the plus and minus in there so you remember it can be both. Okay. Then what goes in the denominator?
Factors of the leading coefficient.
Okay, factors of leading coefficient. So plus or minus 1 and 3. So I have 1, 2, 1/3, and 2/3 that I could choose from. Correct?
Mm-hmm.
Where'd I get 1/3 and 2/3? The using lining them up different, right? Okay, so what do you guys want to start with? 1, 2, 1/3, or 2/3?
2.
2? Okay. So 2. So, I had no gaps, right? So all your rules on gaps and everything else apply. So I get 3, 6, 10. I think I'm going to stop. Why did I stop?
Because you're not going to be able to use it.
Right, because I'm going to go, what's going to happen on my next time? 2 times 10 is what? 20. So I'm not going down to get a 0. I'm going to have a big number, right? I mean, I guess we could. 20. Then we'd have 22. I'm feeling worse and worse about this because I'm now going to have what? 44. So 2 didn't work. So let's make the 2 a negative. And what I would do is I just erase the little bit I did. Because 2's already written there, right? So just try the negative. So that'd be what? Negative 6, negative 2, 4. Oops, I multiplied, not added. 6, negative 12, negative 13. Is it going to work?
No.
No, 2's not going to work. So 2 out of there. And on your paper, just go like that. Just cross it out. Okay, what else do you want to try now?
-3?
Well, we don't have negative 3. The only other whole number we have is 1. You guys want to try 1?
Sure.
Okay. That gonna work out for me? So let's try what?
Negative 1.
-1. And guys, I don't know. I have to try them too. I probably could tell you sooner than you could that it's not going to work. But other than that, I can't look at these and go, that's a factor.
It works.
Yeah, it does work.
I would have guessed it had to be a negative because we have so many positives in the front. Okay, so I'm now down from x to the 4th to x to the what? 3rd, okay? And I don't think this is going to factor by grouping, do you? I got 3 and negative 2. That's not going to factor out to something nice, is it? Okay, so we can do our PRZ still, but now we're going to use negative 2 and what? 3? Is that what we had before? Yep. We already know 2 doesn't work. We already know 1, positive 1 didn't work. We can try negative 1 again, or we can go to 1/3 or 2/3. What do you want to try? You want to try negative 1 again? Because could it be a multiplicity of 2?
Yeah.
Yeah. Why not try it before we have to go to those fractions, right? Remember, we just do the repeated synthetic division. So off of our answer, divided by 1, or negative 1. Negative 3, negative 2, 2, 3. Is that going to work for me? No. Okay, so that didn't work. So we know 1's gone. We already used it. So what do you guys want to do? Negative 1/3?
Sure.
Okay. So 3. So negative 1/3 times 3, that'd be negative 1, wouldn't it?
Yeah.
And 0. And negative 1/3 times 0 would be
0.
0. And 1. And negative 1/3, that's not going to work, is it? No. Positive wouldn't work either, would it?
Maybe. Is there 1/2?
Well, I don't think it will. Because if you go positive, then it would be, this, we get a 2 clear back here. And then we'd have negative 2/3. And so then we would have 1 minus, so then we'd have a 1/3. And then we'd have a 1/9. So that's not going to work for us. So what do you want to try now? We only have one thing left.
2/3?
2/3. I think we still have to do the negative, don't you guys?
Yeah.
Okay, so negative 2/3. So 3, well, negative 2/3 times 3 gives me negative 2. Because the 3's reduce. And then negative 1, so that gives me 2/3. Well, 2/3 plus 1, so the 1's a 3 over 3, right? So it'd be 5/3. And when I times that by a negative 2/3, that's negative 10/3. That does not give me 0, does it?
No.
No. So, we got a problem. What's our problem we got?
We can't do it.
We can't do it.
Yep.
So what can we do?
Give up.
No. Never give up. What?
That's our problem, right? X to the third.
Yes. Let me get rid of. She's saying she's looking at.
Didn't we do x squared for the quadratic equation with x thirds?
So we have 3x to the third plus x squared plus x minus 2. Say that again?
Didn't we do x squared for the quadratic equation for x to the third?
Well, no, we did for x to the fourth. When you had like x to the fourth, x to the fourth, and then you had square. Anytime you have like, we could have 6 and 3, 8 and 4. Anytime our powers were half, we could do the quadratic formula and leave like that out there. But that didn't help. So what are some other options?
Factor by grouping?
Hmm?
Can we factor by grouping?
Oh, we didn't do one yet. We can't factor by grouping because I think this 3 and that 2 are going to cause us some problems. Okay, we did negative 2/3, but we didn't do what?
Positive?
Did we do? I don't think we did positive 2/3, did we?
No.
Okay, like it just hit me that we hadn't done it. So first you got to make sure you do everything, right? Just because you don't like the number doesn't mean it doesn't work, right? So, okay, so that's 3. So 2/3 times 3 just gives me 2. So it gives me 3. Well, 2/3 times 3 gives me what again?
2.
2. And I get 3. And I get what again? 2.
Zero.
And a 0. Woo woo. So now we have 3x squared plus 3x plus 3.
Can factor a 3 out?
Now we can factor a 3 out. I got to erase this work over here because you guys have more room on your paper than I do. So if I factor out a 3, I get 3x squared plus x plus 1.
Yeah.
Okay, so now do the factors of 1 add to 1?
Yeah. Oh, no, sorry.
No. So we can't factor it that way, but can we use the quadratic formula now?
Yeah.
Yeah. Okay. So what's the quadratic formula? You fill it in for me. X equals,
Negative b plus or minus the square root of b squared minus 4 times a times c
all over.
2a.
Okay, so negative 1 plus or minus the square root of 1 minus 4
times 1.
over 2. Well, we knew it was going to be imaginary, didn't we? How did we know it was going to be imaginary? Did we already try everything else?
Yeah.
I guess we could have tried 2/3 again. I didn't want to try 2/3 again. How about you? No. Okay, so this is going to be negative 3. So x equals negative 1, 2/3. And if we have the square root of negative 3, that's negative 1 plus or minus I squared of 3 over 2. Now, I didn't separate it and write it in the standard form for a complex number, but that's not really the point on this one, is it? No. So I have two real zeros. Oops, I just erased it. I have two real zeros, and I have two. Why do I have two? Because it's plus and minus, right? So I have two real, and I have two imaginary. So 2 plus 2 is 4. And is that what we should have had? So you can guess good or you can guess bad and have a long day, right? So hopefully you're paying attention as you're guessing, that they turn from guesses to educated guesses. Does that make sense? Now, I told you I probably would have guessed the negative on the one because of the positive, positive, positive. We had to get a negative in there somewhere, right? Unless we just keep it bigger. Why didn't we have to have the negative on this one? What helped us out? The 3 reduced, right? We kept getting 3s that reduced. So our number didn't continually get large. It kept staying about the same, didn't it? Questions? Yes?
Yeah, I don't understand.
That's not a question.
No, that's not. I was gonna say more. I don't understand, like, why do we gotta do the PRZ? What does it help us with?
Because you can't factor this or do the quadratic formula. We found the zeros of this function. Now we couldn't graph it.
So you're doing the PRZ to help you get to do the quadratic formula.
Mm-hmm. Because this is a 4th degree. We have nothing to help us unless it's the 4th, the squared. We have nothing to help us other than long division.
Alright.
Okay, what are all the possible rational zeros? Do it. Oh, wait, no, sorry. This one says what are, I was doing the PRZs in my head. Okay, so what do we start with? This one isn't on your own, but unless you want to be on your own. Okay, so we have to find all the complex zeros, roots. Roots are zeros, okay, guys? How many are there? Look at the equation. How many are there? 3. There's exactly 3. Okay, real, imaginary, we don't know, but there's 3. So our PRZs, you got them yet?
No.
1, 2, 5, 10.
1, 2, 5, 10.
Yeah, over 1.
Okay. Oh, that's nice, right? Now, could I factor this by grouping?
Yeah.
You think?
I think so. Oh, the x cubed might get in the way though.
If I could factor by grouping, should I?
Yes.
Yes. Okay, so do you want to try?
Yeah.
Okay, what do you want to group? Because it doesn't matter which 2 things I group as long as I group 2 things, right?
First 2 and then 1.
First 2, last 2. So factor out an x squared. So get x minus 2. What are you going to factor out the last 2?
5.
Positive 5.
Yeah.
And get x minus 2. So did I have to do long division on this one? No. So I have x squared minus 5 and equals x.
Plus 5? Yeah, plus 5.
Oh, yes. Plus 5. My hand was covering it and I saw the minus. And then x minus 2.
Yeah.
So I have to do what next?
Solve them.
Solve them. Set them equal to 0. Well, on x squared minus 5, or x squared plus 5 is going to be x squared equals negative 5.
Yeah.
And then I do the what?
The square root.
Square root. So let's put the 2 first. How about that? Where'd I get the 2 from?
Root x minus 2.
X minus 2. Okay. So then what does this get me? What do I get?
I square root of 5.
How about plus or minus?
Plus or minus
I square root of
5.
5. So how many roots did we have to find?
3.
3. How many roots did we find?
2.
Nope.
3. 5.
Because the plus and minus makes that 2, right? Now, what's another name for roots?
said it earlier. Zeros.
But it's another name. Solutions.
Yeah.
X-intercepts. Now, I wrote them this way for a purpose. Roots and solutions can be real and imaginary. Yes? This is on the complex number system. But what about zeros and roots? Can they be imaginary?
No.
I mean, zeros and x-intercepts. Can those be imaginary? No. This is on the real number system. But do we find them all the same way?
Yeah.
You set it equal to 0, and you factor. Factoring is division, yes? Synthetic division is division. All of these methods we have to find zeros is basically division. Except for quadratic formula. It's not. It's the quadratic formula. Tell me when you're ready, Elf. Good? Everyone good? Okay. So a conjugate root theorem. This is actually really easy, guys. When we did conjugates, you remember what a conjugate was?
No.
No one in here remembers what a conjugate is.
I remember the word.
X minus 5, x plus 5. The difference of squares. Yes?
So what's the difference of squares?
Well, this is the difference of squares. It's
X
the
plus 5. Combined and
okay. This is the difference of squares. Conjugates are them factored. Okay? So, those are real conjugates, yes? A complex conjugate has a what in it? It has an I in it. So I have x minus 2i. I also have what? X plus 2i's. Okay, it happens even with real number conjugates. If one, but definitely here, if one is there, if all I do is write down this one, what do you also know? That one. I don't even have to write it down. You should also know it's there. Okay? If you get x minus the square root of 6, what also has to be there? X plus the square root of 6. Okay, the conjugate root theorem says if one is there, the other one is there. If I have a minus the square root of b, I also have a plus the square root of b. If I have a plus bi, I also have what? A minus bi. And where's the I come from? The square root of a negative 1, right? So that's why they're there. So if I told you to tell me the polynomial where I had 1, 3, and negative I as solutions. So these are solutions. What came before solutions? How did I get these? The factors, actually, right? And what did I do to a factor to get a solution? I set it equal to 0. So you have x equals 1, x equals 3, x equals negative I. What's the other one we know has to be there? X equals positive I. Now, how do I make those factors? Move them from the right to the left. So I have x minus 1 times x times x times x minus I, and then I would FOIL these out, correct? I would multiply these, and when I multiply them, am I going to have any i's left? No, because that's the whole point of a conjugate, right? I would have x squared plus 1 when I FOIL them out. And when I FOIL the other two out, I would have x squared minus 4x plus 3. And then what would I do with those two things? What's it say to do? What's that mean? Multiply them. So I would distribute to each one and distribute to each one and combine like terms. Correct? So they're going to do that. They're going to say, here are the factors. Give me a polynomial. All we did, we went from zeros to factors to multiplication to get the polynomial.
Okay.
That's it. So, what is the quadratic function p with rational coefficients of standard form such that p of x equals 0? P of x equals 0 has x plus 5 as a root.
2 plus 5, right?
Or 2 plus 5, not x, sorry. So we have x equals 2 plus 5i as one of our roots. Why do I say one of our roots?
Because it's
What's the other one has to be?
2 minus 5.
2 minus 5i. And it's quadratic, so what's your degree? 2. So it wants the polynomial, so I have to put the zeros back into what? What did we just do on the last slide? Zeros come from factors set equal to 0, right?
Yeah.
So we need to put them back. So we have x equals 2 plus 5i, and x equals 2 minus 5i. I think I said minus both times. Now, how do I move all that stuff over to the other side? How do I move the 2?
You minus it over.
Subtract it over. How do I move the 5i?
Minus it over.
Subtract it over. So I have x minus 2 minus 5i as a factor. Because we said it equals 0.
How is it minus 5i?
Because this is a positive.
Yeah, but you're subtracting it over to a negative.
Yeah, but the 2 isn't like terms. You can't remember complex number, imaginary numbers and real numbers. You can't combine.
Yeah.
They're not. This is it. Like I can't combine anything. Okay. What about the other one?
X plus 2 plus 5.
No.
X minus 2 plus 5.
X minus 2 plus 5i. What is the only sign that changes on a conjugate? The one in between what you're conjugating, really, right? Okay, I know why you said it. That's why I put this problem in here. So now what do I have to do with these two things? Foil. So foil them. Sam, you get that? Gold, did you get what I got?
Hmm?
Did you get what I got?
Sure.
How'd you get?
Alex, did you get what I got?
I'm not done yet.
Okay. Cooper, are you still working? Austin, you still working?
I see how you got it.
Somebody asked how I got what.
How did you get that positive 4 out?
Oh, I forgot it.
What's that?
Because normally I would have done this, and I didn't want to cross them out because I wanted you guys to see them. Sorry.
So is that 20?
No, 29.
20.
Yeah. Because the negative, what does this I squared do? What is that? Negative 1. So negative 1 times negative 25 makes it a positive 25. So it's plus 29. So can you guys see how everything we've done in the chapter has come together in this section? Did you see that?
Fabulous.
Yeah. Now do you know why I kept going over it again and again and again? So if a factor is imaginary, we don't have imaginary polynomials usually, do we? So when we're done, all that should be gone. Questions? Okay. What is the quadratic equation in standard form with rational coefficients that has 5 plus 4i as a root? I want you guys to try it.
What?
It's the same question you just had, but I have 5 plus 4i. So you're going to do exactly like we did the last example, except with those numbers.
Would it be 16i squared?
Oh, yeah, I forgot my 1. Yep, I just wrote the 6. So that would be 41, right? I don't even know why I would forget my 1 on my 16. That's weird. Yes.
Would it be negative 41?
No, because it was negative 16i squared. So that's negative 1.
How'd you get 41?
16 plus 25. Other questions? Okay, I think we're going to do one with a square root. Yes. Ooh, and a 5i. We can do this one all together.
What was the answer to that last one?
Oh, I'm sorry.
X squared minus 10x plus 41.
Okay.
I'm sorry, Alex. Are you okay?
Yeah,
Good.
I got it.
Okay. So, well, we know x is equal to 2 minus the square root of 3 and 2 plus the square root of 3. We also know 5i and negative 5i. So we're going to have four factors. Now you notice this does not say quadratic, does it? It just says what? Polynomial. And it does tell you the degree of 4. Do we now have 4 roots? Okay, so what's my first factor going to look like? X what? You're going to have to subtract the 2 over, so negative 2
X minus 2 plus square root of 3.
plus the square root of 3. And then I'm going to have x minus 2 minus the square root of 3. And then I'm going to have x minus 5i, x plus 5i. Hopefully that you could already tell me that this is x squared plus 25. Why would I say that? Is it x minus 5i and x plus 5i, that difference of squares? And when without the I, it would be negative 25, right? But with that I, it changes it to a positive.
Yeah.
So you're going to FOIL this out. Do you think we have enough time to do it quick?
Yeah.
Okay, so we have x squared minus 2x minus x squared of 3. And negative 2x plus 4 plus 2 square root of 3? No. No. X. Yep. Sorry. I was trying to skip. And then I have plus x square root of 3 minus 2 square root of 3. And the square root of 3 times the square root of 3 minus 3. I know I did that fast. So x squared minus 4x plus 1. Okay, now what do I do with these two? I have to FOIL them again. I'm going to go the small one with the big one myself.
How did you?
What? How did I do what?
Why'd you do that so fast?
Because I was trying to do it before this. Okay, so I'm going to FOIL this out. You guys can go. I'll finish this, and then this is the last example anyway. So x to the 4th minus 4x cubed plus x squared plus x 25x squared minus 100x. You guys, I'm still recording. 100x plus 25. So good. X to the 4th minus 4x cubed plus 26x squared minus 100x plus 25.